Welcome back. Week 7, day 1. Today we're going to see a new topic. Today is February 14th, 2022. Remember to place the date at the very top of the page and leave an empty space for the topic's name. And as usual, we're going to begin with some definitions. I have already here written the definitions that we're going to see today. The first one is system of linear equations. What are those? Or those are systems are when we have two or more linear equations and they are graphed in one same coordinate plane. There are different ways of solving a system of linear equations. One of them is by graphing. We are going to see the other two until next school year, okay, which are by elimination and by substitution. Now, the solution of a system. Well, the solution of a system is any order pair that will be a solution for each equation in the system. Sometimes we might have systems of 3 or 4 equations, and we're going to have as many variables as equations we have. We will be working only with 2 right now. Okay, so if the solution is true for both equations, then that is a solution of the system. If it's true only for one, then it is not a solution of the system. It is a solution of the equation, but not of the system. We will be working with 3 types of solutions. The first one is one solution. When the graphs of the 2 lines intersect in one point exactly, when they touch and they cross and they touch in one point exactly, that point is the solution of the system. Remember, we're working with ordered pairs because we're working with 2 variables, x and y. Therefore, we have an ordered pair, x, y, which will be the solution of the system. Then we have another one, which is called infinitely many solutions, or just many solutions, okay? And when is that? When the graphs of the 2 equations are the same line. All the points of the line are the solution. It's like you're graphing one line, and then the next line is exactly the same one, okay? So they touch in every single point. Remember, a line is made up of a lot of points one next to the other. Well, in this case, they touch every single point because you're exactly the same line. And no solution when the graphs of the 2 equations are parallel and there is no point of intersection. Now, do you remember what parallel means? What does parallel mean?
They're not touching. They're not touching in any way.
Can you give me an
Like
example of your fingers?
Yes, like this is what the finger of my right hand. My left hand, and this is the finger of my right hand. They're not touching.
Exactly.
They're not touching.
Exactly.
They're not touching.
Exactly, Elisa. Very good. So those are parallel lines when they are one next to the other, but they will never, ever, ever touch. Okay. They will extend infinitely in both directions, but they will never, ever, ever touch. Since there is no point of intersection, there's no point where they touch each other, then that is when we have no solution. Okay, and how are we going to graph these systems? Well, remember, you already have 2 methods of graphing, the input-output table or the slope-intercept form, okay? Those are 2 forms of graphing your equations or your systems. There's another way where we can graph our systems, okay? And it's with the intercepts, okay? That will be the other method of graphing. So I'm gonna show you right now, we're gonna graph a system in different ways. We're gonna graph 3 systems, one with an input-output table, one with the slope-intercept form, and one with the intercepts, which is the new form, okay? So I'll begin with the intercept so you understand better this new method. So let's say that we have the first system, y is equal to x plus 1 And y is equal to 3x minus 9. No, minus 6. This is your system, okay? There are two equations. This is your system. I'm going to show you how to graph them using the intercept. The first thing is to identify one equation as equation 1. This one in blue will be equation 1. And this one in black will be equation 2. Now, for equation 1, I'm going to work with equation 1 first. I'm going to do it all in blue. Y equals 2x plus 1. So remember, you can use different methods, but right now I'm showing you one new method, which is called the method of the intercepts, okay? Remember, y-intercept is the point where, at that point, it is exactly on top of the y-axis. Therefore, the x-intercept is the point that is exactly on the x-axis, horizontal. So we're gonna say intercept as an I in the x-axis, ix. We're going to say that that is when we are looking for x, so we leave an empty space, and y is going to be 0, okay? For the intercept in x, y is going to be 0, always, okay? So you're going to substitute that 0 in the equation, okay? You're going to substitute it. So you're going to say 0 is equal to x plus 1. And now we're going to solve for x and leave the variable x completely alone and positive in one side. Therefore, this 1 has to go to the other side, subtracting, right? Okay, so we say negative 1, because 0 minus 1 is negative 1, equals 2x. And that number is the one that we're going to place in this empty space. I'm going to place it in green. So negative 1. And that is the intercept in x for this equation. Now, intercept in y. I'm going to do it over here. Intercept in y. It is when x is equal to 0 because we're looking for the value of y. So we're going to substitute in this case the 0 in the x. Okay. So let me move this. And let me erase that. Now we're going to place the 0 in the x. So we're going to say y is equal to 0 plus 1. Which is 0 plus 1? Which is 0 plus 1?
1.
So y is equal to 1. And that 1 is the one I'm placing over here. And I got now the two intercepts that I need for my first equation. Okay, so I can go ahead and find the intercepts for the second equation, or I can go ahead and graph this first part. I will go ahead and find the intercepts as the second equation. So for equation 2, y is equal to 3x minus 6. And I'm going to do exactly the same procedure where the intercept in x is when I'm finding the value of x. So I'll leave an empty space, and therefore I'm saying that y is equal to 0. And I'm going to substitute the same way, okay? So I'm going to say 0 is equal to 3x minus 6. Remember, we need to leave the variable x alone. So this negative 6 goes to the other side with an inverse operation, which is positive. And we get that 6 is equal to 3x. But I need to leave the variable completely alone. Therefore, this 3 goes to the other side, dividing. And now I have that 6 divided by 3 is going to be equal to x. How much is 6 divided by 3? 2. So 2 is equal to x, and that 2 is the one that I'm placing over here because we found the value of x. Now, since I don't have no more space over here, I'm going to do it over here. Intercepting y is when x is 0 and we're looking for the value of y. So I'm going to substitute instead of x, 0. So y is equal to 3 parentheses. Remember, we place a parenthesis when we substitute, times 0
Miss,
minus
the
6.
number that is with the y is a 1, right?
I didn't understand.
The number that is with the y is a 1.
Yeah, there's an invisible 1, correct. Now I'm going to eliminate this because 3 times 0 is 0. And what do I have left? Y is equal to negative 6. And that negative 6 is the one that I'm placing in my empty space. Okay, now I'm ready to graph. And in this case, since we're graphing systems, we are going to use 2 different colors. First, you're going to graph the points with pencil, and then you're going to connect them with colors. Okay, you're going to use colors. So you need to make sure that they are correctly graphed. So I'm going to graph. As you see, I need negative 6 on the y, 1 on the y. I need negative 1 on the x and 2 on the x. So I think that I can graph it. Oh, let's graph it in black.
Miss, that line we have to do it in another page, right?
It could be right there where it is already.
Ya no me cabe.
English, then do it in another page. If it doesn't fit, then do it in another page. Okay, remember to draw the arrowheads. I'm going to do equation 1 in blue and equation 2 in green. Okay, so in blue, equation 1, negative 1 comma 0 on the x, so over here, and 0 comma 1, so over here. And I'm going to connect those two with a straight line passing through the center of each point. Oh my God, this mouse is just like crazy. You see, it's crazy, the mouse. Okay, there. I draw my arrowheads. Sometimes I need to extend it a little like past my coordinate plane, as you can see. That will be fine. Now in green, we're gonna do this other one, equation 2 in green. 2 comma 0, so 1, 2 on the x, and 0 comma negative 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So over here. And again, I'm going to connect those 2 points with a straight line passing through the center of each point. And I'm going to extend it. I'm extending it, okay? Now, do I have one single point of intersection? Do I have all of the points of intersections, or are the lines parallel?
Yes, Miss, there's a point of intersection.
Here is one point of intersection, right? And it is over here. So how many solutions do we have? How many solutions do we have? One solution. And that is the answer. In this particular case, since I changed the exercise that we have in the book, and that's fine, okay, it will be fine. It is a decimal. As you can see, it is a decimal. So, más o menos, kind of, what would be our answer? So this is 2, 3. So this is 3. And this is 4. And this is apparently 3.5. So 3.5, comma, 1, 2, 3, 4, 4.5. So this is apparently 3.5, comma, 4.5. And that would be the answer of my system, okay? That's what would be the answer of my system. Now, how can I be completely sure I need to substitute this in both equations. This is just how we prove that our answer is correct. Okay, so placing you at the top, and I'm going to show you how we prove that our answer is correct. So apparently there is one solution because there's one point of intersection, and apparently my solution is 3.5 comma 4.5. Since this is made like with a guess, we're sketching that point because we didn't use a ruler exactly. We're going to prove if that's the answer. So we got 3.5. We're going to substitute the 3.5 and the 4.5 over here. Okay, so we got, instead of y, 4.5. So 4.5 is equal, instead of x, 3.5 plus 1. Is this correct? Is 3.5 plus 4.5 equal to 4.5? 4.5 is equal to 3.5 plus 1, it is 4.5. So for this one, it is correct. Let's check for the other one. 4.5 is equal to 3 times 3.5 minus 6. Okay, and we're going to solve this. And how much is 3 times 3.5? That is 10.5. So 4.5 is equal to 10.5 minus 6. How much is 10.5 minus 6? How much is 10.5 minus 6? It's 10.5 minus 6.
4.5.
4.5. So this is our proof, and we know that 4.5 is equal to 4.5. So it has one solution, and what solution it is? It is the order pair 3.5, comma 4.5. And that is your one solution for that system. Questions so far? Remember, this is the new method, intercepts, okay? You can solve it using the input-output table, and you can solve it also using the slope-intercept form. Questions? Do we get it?
We have to upload this.
Cámara. Sorry,
Miss,
Ismael?
we have to upload this to Schoology.
No.
Ah, okay.
In your
So for doing the slope intersection, we can use the table.
You can use the input-output table? Yes, you can use the input-output table. And for
Okay.
this cases, you can use 3 points only. You can use -2, 0, and 2, because you're gonna do 2 boxes, 2 little tables, one for one equation and one for the other one. Okay, so we're
Okay.
gonna still do 2 more exercises about this topic. This is the first part. Okay, we're Just
So
learning.
in this topic, if we use the input-output table, we only use -2, 0, and 2.
0, -2. Yes, no, -2, 0, 2. Remember, negatives go first.
Yeah.
Okay. Any other question? We will be doing another system using the input-output table, and we will be doing another system using the slope-intercept form. And again, one more to remember this new method of the intercepts. So we haven't finished the topic. This is just the introduction. This is the first part. In our next class, we will be working with 3 more systems that we need to be solving. Okay? So don't worry, we're still going to be practicing this a little bit more. Any other question? No. Okay, let's name the topic because it's possible for us to name it already. What is the topic's name?
Slope intercepted.
Happy
No.
Valentine's Day.
System of linear equations.
Systems of linear equation, very good. But what are we doing? What did we do over here with this system? Because this is the system, but what did we do over here? We solved the system. So we're going to call it solving systems of linear equations because we solved the system, okay? So that's what we're going to call it, solving systems of linear equations. And that, boys and girls, is the topic for today.